Okay. So I hope you have understood, you have got about the equations of kinematic equations of circular motion.
Sir, can you once discuss how to change linear velocity to angular velocity like that?
Yeah.
Those.
Okay. First of all, whatever will be the length of arc, suppose if there is any circular object which is revolving, so we know that a length of arc is equal to, so suppose this is a circular path, and on this circular path an object moves in this circular path. So if the object moves in the circular path, then we know that the length of arc will be equal to the distance. Whatever length of arc that is travels will be equal to the distance traveled. And hence, by using the formula of theta, we know that theta is equals to L over R. So we can obtain R multiplied theta is equal to L. Now, if we divide both sides by t, if we divide both sides by time, so we'll get here R multiplied theta by t equals L by t. Okay. So theta by t is the angular velocity, so we can write it as R omega will be equal to L by t, which is linear velocity v. So we have the formula v equals to R omega, by which we can relate uh, angular velocity with the linear velocity. Okay. So yesterday I gave you some of the questions. Were you able to do those questions? Yeah, Pritam, could you do those questions?
Yeah, first two.
Okay. Any problems in any of the questions?
No.
Okay. So for today we will be doing work and energy. Today we'll do work and energy.
What is it? A new chapter? Okay. There is a new
Okay.
chapter.
Yes,
Look at the new chapter.
you are not audible clearly. Can you speak a little bit louder?
Is it another chapter?
Mm, it's a subtopic. You can say, see, currently we are not taking the complete chapters into depth. We are just doing bits of those which will be just help you out once we start in deep, right? So we are not going into complete depth of each chapter. Like
Yes.
before that, you have your motion, you have vectors, but those topics we are not touching right now.
Is there any
That is,
chapter called motion in straight line?
yeah, you have motion in a straight line. So, but that we are not doing. Currently, we are not doing that.
Okay.
Okay. You see some basic fundamentals or some basic things about work and energy. So, what is work? First of all, how we define work. So, work is said to be done when work is done when a force displaces an object. When a force displaces an object, then we say that some work has been done. Right? So first of all, there has to be a force and there has to be some displacement of the object. Then only we will say that some work has been done. Now, depending on what type of force is there, in which direction is displacement, there are different types of work that can be done. So suppose if you have a block and you try to push this block with a certain force. This is what you have studied. But here we will be talking. Suppose you are trying to pull this block along this direction. This is the direction along which you are supposed to pull this. And now suppose you apply a force F on this block. So in this direction, you are supplying a force F, making an angle theta with the displacement. So here force makes an angle theta with the displacement S. Now, what will be the amount of force, the amount of work that has been done by this? So the amount of work done, so here amount of work done is equal to the force multiplied displacement, but in the force component of force in the direction of displacement, right? So if you see here, whatever force is used, this force has two components. That means it is working in two directions. Working in two directions means some part of this force is utilized to lift up this block. A part of the force is being utilized to lift up this block a little bit higher so that decreasing the load on the surface, and some part of this force is used to displace this. So this force which is acting at an angle theta. So some part of the force is acting along the y direction. We call this as the y component of the force, which is Fy. Some part of the force is acting along the x direction, which we call as Fx. Okay. So which component of the force do you think is responsible for the displacement? Force along the y direction or force along the x direction?
Why?
Force along y direction? Which force is responsible? Force along y or force along x?
See both.
Both. See here, if you apply a force only in y direction, here if we apply a force only in y direction, suppose there is no force in the x direction, we are applying force only in y direction. So in that case, the block will be lifted up and there will not be any displacement along the x direction. Will there be any displacement?
No.
No. And if the same force act along the x direction, if the same force act along the x direction only, there is no y component. Suppose this force act along the x-axis, so there will be only displacement, right? So we will say that the force along the x-axis is the force which is responsible for the displacement of this object. So therefore, we will write work done to be equal to work done will be equal to Fx multiply displacement. Okay. So this is also written as Fs cos theta, where Fx is equal to F cos theta. Or it can also be written in other form. It can be work done, can be written in the form of F dot S. Okay. So why the symbol dot has a different meaning? The symbol dot, it has a different meaning. It means that uh, it means a dot product. Whenever two vectors are multiplied. Yeah, Jaswant, you had some issue? Jaswant? Jaswant? Okay, see. So the work will be given by Fs cos theta. This is the formula you can remember, that work done by a force is given by Fs cos theta. And as the second thing I have written is work done will be given by the dot product of two vectors, where the vectors, as we know, that force and displacement, both of them, they are vector quantities, right? Force is a vector quantity
Yeah.
and displacement is also a vector quantity. So to
Yes.
multiply two vectors, we do not have the same logic as we have been doing till now. Till now, whatever multiplication we have been doing, that we call as the scalar multiplication. Okay. To multiply vectors, we have two methods of multiplication. That means the way you multiply, it's not the same thing every time you will be doing. There are two types of vector multiplication. One is we call as the dot product. You call dot product, and the second one is vector product. Vector product, or we also call it as cross product. We call it cross product. This dot product, or we also call it as scalar product. So see, where all do we use scalar products? If two vectors are multiplied with each other and you get a scalar quantity as the answer. If you are getting a scalar quantity as the answer by multiplying two vector quantities, then we use dot product. For example, work done is obtained, work done by a force is obtained by multiplying force and displacement, where work itself is a scalar quantity, but force and displacement, they are vector quantities. So therefore, work done will be calculated, or work done will be obtained by finding out the dot product. So work done will be obtained by finding the dot product of the two vectors. The dot product or the scalar product of the two vectors will give you the dot product. The second, you have vector product. Vector product means you have two vectors multiplied. If you multiply two vectors, so two vectors are multiplied to give you a vector as the answer. Okay. So if two vectors are multiplied to give you a vector as the answer, then we use the vector product. So we will see, yes, there are cases where we get a vector by multiplying two vectors. So a vector we obtain by multiplying two vectors, that at that place we will be using the vector product. Now, how can we define the dot products? There is a general definition of dot product. Suppose if you have two vectors, the vectors be vector A and vector B. We'll write like this. By writing the letters and making an arrow above it, we read it as vector. So this will be written as vector A. This will be read as vector B. Okay. So vector A and vector B. Now we will write it as, if I write A vector dot B vector, it means the scalar product. And this is given by the formula A B cos theta. Okay. Where A and B, they are magnitudes of the vector A and B. So you will be just multiplying their magnitudes and multiply it with the cos theta, multiply it with cos of the angle between them. Okay. If you have the cross product of A and B, so the cross product of A and B will be given by the formula A vector cross B vector would be equal to AB sin theta. So this is how we obtain the cross product of the two vectors, AB sin theta. Got it?
Yes, sir.
Okay. So now the work done. We'll discuss about the cross product later. First, we will discuss mainly about the dot product. So if you have a force and a displacement, you know the angle between them. So you can find out the amount of work done. For example, let us say a small case. A cycle moving with 20 meter per second is brought to rest by applying force or by applying brakes. Okay. So a cycle moving with 20 meter per second is brought to rest by applying brakes. The cycle stops after traveling a distance of, so the cycle stops after traveling a distance of 5 meters. Find the work done by brakes. Okay. So find the work done by brakes if brakes apply a force of 35 Newton on the wheels. Okay. So who can do this question? A very easy question. What should be the answer? Yes, what should be the answer?
7.
Yes,
7.
7. How do you get 7? Okay, let us try to understand this. The question is pretty simple. You are given the force, you are given the displacement, right? So what is the force given here? What is the force applied by the brakes? Can I
35
say
Newton.
that the 35 Newton? So force is given as 35 Newton and displacement here is given as 5 meters. So I
Yes,
can
sir.
clearly find out the work done. But there is just one thing we need to see. See, the brakes are applying a force in a direction opposite to the direction of motion. The brakes are applying a force so as to oppose the motion of cycle. Okay. So the direction of force, suppose the cycle is moving along the positive direction or along the right direction. So if the cycle was to move in the right direction, something like this, suppose a cycle was to move like this along the right direction and you apply the brakes. So the direction of displacement will be in the right direction, but the direction of force would act in the opposite direction. The brakes would apply a force in the opposite direction of the displacement. So here we have an angle between force and displacement which is 180 degree. We have theta as 180 degree. So now if we find out the work done would be given by F as cos theta. So F as cos 180, right? Force here given to us is 35 Newton. Displacement given to us is 5. And the value of cos 180, you should remember that the value of cos 180 degree is -1. See, up to now in your grade 10, you had done the trigonometric ratios only up to 90 degrees, right?
Yes, sir.
Yeah. So trigonometric ratios, they are defined for all the angles. And how they are defined, you will see later. You will see later in mathematics, you will see in physics also will tell that how the different trigonometric ratios are different. Okay, but for now, for this topic, we memorize that cos 180 degree is going to be -1. Okay, so there will be a negative work done by the frictional force or by the force applied by the brakes. You will have a negative work done, and this should be equal to a negative of 175 joule. A negative 175 joule of work will be done. Yes. Okay. Let us try to do this one. Okay. Find out the amount of work done in these three cases.
Yes, sir.
Sir, can you hear me? Sir.
Yeah, just one. You are audible now. So here I am giving you three cases. You have to give the amount of work done. Okay, see. In the first case, you have a force and displacement. So here the angle between them, the theta is going to be 30 degree. You have force which is 25 Newton, and you have displacement. It's being displaced from this position to another position here, such that the displacement between them is say 15 meter. Okay. So find out the amount of work done for this first case. Okay, find the work done for this first case. In the second case, the object has an initial velocity equals to 10 meter per second. A force act on this block in the opposite direction, like this. The initial velocity is along this direction. A force F along this direction, and this force F is 5 Newton of force acting, so that the block is stopped over here, and now it travels a distance of again 15 meters. Here in this in the third block, there are two forces which are acting. You have some force being applied over here. You have a force applied, and you have a force of friction. You have 10 Newton of force being applied, and you have 10 Newton of force of friction. Okay. So both these forces, they are acting on the same block. Now you will tell that what will be the amount of work done.
Sir,
Yes.
first one is
Yeah, what's the answer for the first one?
1 minute. 318.75 joules.
For the first one, okay, I'm writing your answer, what you are getting, okay? You are getting
That
318,
8.75 joules.
318.75 joule. Okay, I'm writing your answer. I'm not checking. Okay, what's for the second one?
I know third one is 0.
Okay, third one is 0. For the second one,
7. The root 3 value is 1.73, right?
okay, root 3 is 1.73.
So then the first one is 324.3, so sorry.
Okay, so see, if you have, you will be getting your answer. Work will be equal to Fs cos 30, and force is 25, displacement is 15, multiply cos 30. So cos 30 is root 3 over 2. So you have to multiply them all and divide by 2.
375. There it
Yes,
is 320, 324.3.
Okay, you get 25 multiply 15. That's 375. And 375 you need to multiply by 1.732. 1.73, which is 649, and divided over by 2. So yeah, you get 324 joule, right? For the second one, yeah, you are correct for this one. What will be the value for second one?
So one minute. The displacement is 15.
Yeah, displacement is 15 meter.
Force
You
is
observe force is 5 Newton, but acting in the right direction, acting towards left, and the object has an initial velocity of 10 meter per second towards right.
10 meter per second.
10 meter per second towards right.
Okay, sir. Plus 5 theta. So what is
Yes.
cos 180?
Cos 180 is -1.
It's minus 75.
Okay. So you get here, here we get work done equals Jaswant. Are you able to attempt these questions?
Sir, yes, sir.
Jaswant? And for this one, you'll get your answer as Fs cos
Cos
180. The value of force is 5 Newton. Multiply displacement, which is 15, and multiply cos 180, which is -1. So you get -75 joule.
Yes, sir.
And for the third one, we get the
0.
work done is equal to 0. Okay. So we can have sometimes here we observe that the net force on the object is 0. Sometimes it can happen that there is a net force, but there is no displacement. So what should be the work done in that case?
Like
Yes. What should be?
minus 100.
No, something like this. See, suppose you have a wall, and on this wall you apply some force. Here you apply some force. This is a wall, and on this wall you are applying some force, F. We observe here that there is no net displacement. Here displacement is equal to 0. There is no net
0.
displacement. Okay. So what should be the work done?
0.
0. Here we have work done is equal to 0. Right?
Yeah.
So we get here 0 work done. Our work done is 0 joule. Okay. So this is the case of where we have some force, but there is no displacement, and hence the work done will be 0. Okay. Now the next concept is energy. Just after the work done, we have the energy. What is energy now? So can we define energy? How can we define energy?
Used to
Hmm? Yeah, just one.
It's a physical quantity which
Hmm.
gets transferred,
That
which is
stands
released.
that stands for
Sir, like for
power.
heat to light or
okay, ability
some.
to do work. Ability to do work is called energy.
Capacity to do work.
Yeah, ability or capacity to do work is called as energy. Okay. So we have seen energy in different forms. We have seen energy in the chemical form. We have seen energy in the form of light. We see energy in the form of sound. So we have energy everywhere around us, but it occurs in different forms. Okay. Here, mainly we are interested in the mechanical energy. Okay. So in this context, we'll be mainly talking of the mechanical energy. So what is mechanical energy? It is the sum total of kinetic and potential energy. Okay. So the energy which is mainly responsible or which is related to the motion and configuration of an object is called as the kinetic energy. So kinetic energy or mechanical energy is the sum total of kinetic and potential energies of an object. So the sum total of both kinetic and potential energy is called as the mechanical energy. Got it?
Yes.
Okay. So I think you have heard about kinetic energy also. You can define kinetic energy. So what is kinetic energy?
The energy, like when an object is moving.
Okay, energy of a moving object is called as kinetic energy. And if an object is moving, so it possesses some energy, and that energy is called as kinetic energy. So can I say, how can I prove that the kinetic energy is present in a moving object?
By knowing if it is the
Yeah.
does the friction.
Okay, consider a ball. I think all of you have played cricket. So consider you playing a cricket ball, and once that ball hits a window, so what happens over there?
Breaks the window and make the
Yeah,
force makes the
it will
force
break.
little low.
Yeah, it will break the window. The window will break. It will break the glass. So do we observe that some work is done? Can we say that some work is done over here?
Yes.
The ball has done some work.
Yes.
Yes. So the ball has done some work. It is because the ball had some energy. Because energy is the ability to do work. So ball had some energy because of which it was able to do the work. And hence we will say that the ball has energy, and the energy which ball had will be called as the kinetic energy. Okay. In a similar way, consider a moving train hitting a truck. So can I say that the moving train has some energy?
Yeah.
Yes. The moving train has some energy, and hence it is able to do some work. It is able to displace the truck from its position to somewhere else. So it is able to do some work, and hence the moving train has the kinetic energy. So all the moving objects have some energy, have the ability to do that we call as the kinetic energy. What is kinetic energy? The ability of the energy of a moving object. The energy possessed by an object possessed by an object due to its motion. The energy possessed by an object due to its motion is called as kinetic energy. Okay. Similarly, we have potential energy also. That means an
Object at
object.
rest.
Yeah, it's not necessary that object is at rest. It can happen that the object is moving and still it possesses potential energy. Okay. For potential energy, there should be a change in position or change in its configuration. Configuration means arrangement or its shape. So a change in shape can also bring about the potential energy. For example, a stretched spring, okay, a stretched bow, a compressed spring, a stretched rubber band. All of them, they have ability to do work. Have you played that? You take a rubber band and take a paper over here, try to throw it with the help of rubber band.
Yes.
Yeah. So what happens over there? The rubber band has potential energy once you stretch, so the some amount of work is done. Okay. Okay, just one. So we'll continue with this energy topic in the coming next class. Today I'll provide a small test, so do attempt that. Okay, bye, just one.
Okay. Bye.